We are only one step from being able to construct the I-measure mu star. Before we do so, we need two lemmas, which are two identities. One is an identity in set theory, and the other is an identity in information theory. First, we have in lemma 3.7 the set identity which says that mu A intersect B minus C is equal to mu A union C plus mu B union C minus mu A union B union C minus mu C. Then in lemma 3.8, we have the information theoretic identity, which says that Ixy given Z is equal to Hxc plus Hyz minus Hxyz minus Hz. Note that these two lemmas are related to each other through the substitution of symbols. Namely, A corresponds to X, B corresponds to Y, C corresponds to Z, etc. First, we prove lemma 3.7. We write mu A intersect B minus C as mu A minus C plus mu B minus C minus mu A union B minus C. Note that by covering minus C throughout the identity, we simply have mu A intersect B equals mu A plus mu B minus mu A union B. Now mu A minus C can be written as mu A union C minus mu C. Mu B minus C can be written as mu B union C minus mu C. And mu A union B minus C can be written as mu A union B union C minus mu C. Now this mu C cancels with this mu C. And so we have mu A union C plus mu B union C minus mu A union B union C minus mu C. Now we prove lemma 3.8. Ixy given Z is equal to Hx given Z minus Hx given Yz, where Hx given Z is equal to Hxz minus Hz, and Hx given Yz is equal to Hxyz minus Hyz. Upon rearranging the terms, we have Hxz plus Hyz minus Hxyz minus Hz. We are now ready to construct the I-measure mu star on Fn. First, recall in theorem 3.6 that a signed measure mu on Fn is completely specified by the values of mu on the unions. This set of numbers can be any set of real numbers. We define mu star by setting mu star xg tilde to be h of xg for all non-empty subsets G of the index set n. That is, the value of mu star on the union of a collection G of set variables is equal to the joint entropy of the collection G of random variables. Now mu star is meaningful only if it is consistent with all Shannon's information measures via the substitution of symbols. That is, the following must hold for all not necessarily disjoint subsets G, G prime, and G prime prime of the index set n, where G and G prime are non-empty. This condition says that mu star xg tilde intersect xg prime tilde minus xg prime prime tilde is equal to I xg semicolon xg prime given xg prime prime. That is, mu star is consistent for conditional mutual information. When G prime prime is equal to the empty set, we have mu star xg tilde intersect xg prime tilde is equal to I xg xg prime. That is, mu star is consistent for mutual information. When G is equal to G prime, xg tilde intersect xg prime tilde is equal to xg tilde, and xg prime tilde is equal to xg. So we have mu star xg tilde minus xg prime prime tilde is equal to xg given xg prime prime. That is, mu star is consistent for conditional entropy. Finally, when G is equal to G prime and G prime prime is equal to the empty set, we have mu star xg tilde is equal to h of xg. That is, mu star is consistent for entropy. Now we state theorem 3.9, the most fundamental theorem in the theory of the I measure, which says the following. Mu star is the unique sign measure on the field Fn, which is consistent with all Shannon's information measures. The implications of theorem 3.9 are the following. Because of this theorem, we can formally regard Shannon's information measures for n random variables as the unique sign measure mu star defined on the field Fn. A consequence is that we can employ set theoretic tools to manipulate expressions of Shannon's information measures. We now prove theorem 3.9. First, recall that the I measure mu star that we have constructed is defined by mu star xg tilde is equal to the entropy of xg for all non-empty subsets G of the index set N. In order for any sign measure mu to be consistent with all Shannon's information measures, it must be consistent with all entropies. That is, mu of xg tilde is equal to the entropy of xg for all non-empty subsets G of the index set N. In other words, mu must be equal to mu star, and therefore, mu star is the unique sign measure that is consistent with all Shannon's information measures. It remains to show that mu star is consistent with all Shannon's information measures. This is shown by considering for all subsets G, G prime, and G prime prime of N, the quantity mu star xg tilde intersect xg prime tilde minus xg prime prime tilde. Now by lemma 3.7, this can be written as mu star xg union g prime prime tilde plus mu star xg prime union g prime prime tilde minus mu star xg union g prime prime tilde minus mu star xg prime prime tilde. By the definition of mu star, this can be written as the entropy of xg union g prime prime plus the entropy of xg prime union g prime prime minus the entropy of xg union g prime prime minus the entropy of xg prime prime. And then, by lemma 3.8, this is simply equal to the mutual information between xg and xg prime conditioning on xg prime prime. And this proves theorem 3.9.